Hi everybody. This is problem 6 from section 9.6, or if in case I don't get to it, it is the class slides example number 3. And here we have a degenerate conic. So let me just for a minute explain what a degenerate conic is. Remember, these are all conic sections that we're studying here, and so for example, I know this is just kind of not a great picture here, but here's our conic section. And if for example it's a degenerate circle, right? We've got all these circles right here. We got the circles, and then the circle degenerates to the place where the radius of the circle is 0, which really means that the circle degenerates to a point which is dimensionless, right? Points don't have we can't really represent them in space because they don't take up any space. All right, well, that's the idea. This is actually, we're going to find that this is going to describe a conic section that is going to degenerate not to a circle, or to a point. It's going to be a hyperbola that degenerates to the two lines along the edge of the conic section. So it goes from a 3D sort of thing that you have to 2D. No, not really, because even really a hyperbola can be represented in 2D. But at any rate, it's the hyperbola is degenerating to these two lines. It's becoming something less than it was, and that's sort of where we get that from. All right, so that's what's going to happen here. All right, let's keep that in mind. Let me see if I can erase all this. There we go, I can this time. Oh, good. Okay. So each point is 3 times as far from the line y equals 5 as it is from the line x equals 1. So just like we do with everything else in this section, we're just going to start by making a pretend curve. I don't know if this is going to be our conic section right now. I'm going to pretend I don't know. It's going to either be a circle, an ellipse, a hyperbola, or a parabola, right? One of those things. And so I'm just going to make a curve out here somewhere, and I'll put a point on the curve. I think I'll put the point right here. Now I'm going to make a line at y equals 5. 1, 2, 3, 4, 5 right here. And I think I'll use the line. Maybe it'll be easier to see if I do that. Here's a line at y equals, I don't quite like that line. Let me try it again. Here's a line at y equals 5 out of there, okay? Now let's do another line. Let me do this even a different color here at x equals 1. We'll let the line, I'm going to make that straighter than my, straighter than I did my coordinate plane there. But this is the idea. All right, so up over here I have the line. This is the line y equals 5, and this is the line right here. This is the line x equals 1. Like that would be 1, 2, 3, 4. And now remember, here's my conic section, just my random. I just drew an arc, okay? And this is just randomly any point on the curve. Don't know what it's any point on the conic section. I don't know what that point is right now. All right, so it's x, y. So I know however many dots, however far over, I know right here the coordinate of this point right here is going to be x, right? Because it's x units over. And the height is going to be y. All right, well that becomes important because now we want the distance from this random point, right here up to the line y equals 5. Okay, we want this distance. We'll call this distance number 1, or d1, d sub 1. And we know the coordinates here. They're not that hard to figure out, right? Because we know it's x units over. We don't know exactly what the x is, but we know that the height is on the line y equals 5, and so we know the coordinates here are x5. Okay. Then coming over here, let's do another color here. I just love all these colors that we can do this. It's too fun. Okay, so now my random point, I just happen to pick this point right here. This is supposed to be a straight line, right? This is the distance. I'm just going to use the distance formula. from my random point xy over to the line x equals 1. And I know, again, this point right here is going to be the point, let's see, x is 1, and y is, I don't know how tall this point is, but I know it's the same height as this point right here, so it's going to be the point 1y. And we'll call this distance number 2. Just distance of 2. It's the distance from the line x equals 1. Now this is worded, not only is this a degenerate, it's kind of a weird problem, but he also words it a little weird. Each point is 3 times as far from the line y equals 5 as it is from the line x equals 1. I mean, what that means, like if I'm 3 times further, right, from the goal than you are, then that means that I am, if I take your distance and multiply it by 3, it's going to equal my distance, right? And so I think what this means here, 3 times as far from the line y equals 5 as it is from the line x equals 1, I think this means that the distance to the line y equals 5 is d1. I think it means that d1 is 3 times d2, which that means my drawing is very, very, very bad. But that's okay. I mean, we get the idea, right? d1 should have been a lot larger. So d1 is 3 times d2, because d1 is the distance to the line y equals 5. That distance is 3 times the distance from the line x equals 1, which is d2. All right, so that's really, this is the hardest part. I always find this to be the hardest part of all the problems. They all get set up this way, and this is what we do. All right, so d1. Distance 1 is just distance formula, right? I got 2 points. I got this point right here, xy, and I got this point right here, x5. And so the distance between those 2 points, here I'll even keep it in this lime green right over here. Let me even move this. I don't want to move that, excuse me. I'm going to move this. Okay, I'm not having success here. Come on. There we go. Let me move this down over here. Maybe right here even. Okay. Let me see if I can get this done now. All right. D1. D1 is going to be this distance right here. And so I can see here it's going to be the square root, just using the distance formula, of the change in the x coordinates squared. Okay, plus, and then the change in the y coordinates squared. So it's going to be y minus 5 squared. And that's going to equal 3 times the square root of, and then I can see here d2. Now d2 is going to be x minus 1 squared, and then plus, and then y minus y squared. 1d squared right over here. Okay, which is nice, because then I can see that, you know, this goes to 0 right here, right? And so this is just going to be the square root of y, that's the distance here. The square root here is going to equal 3 times, and then this goes to 0 also, so 3 times the square root of x minus 1 squared. All right, now, like from here, a couple things I can do, and I'm gonna do both of them. But I just want you to see that, you know, this is actually how your computers often do this, the absolute value function. If you take a number, you square it, then you take the square root of it, you will get the absolute value of the number. The absolute value of the number. And so think about that for a little bit. That's just really what we're having. You know, if we take the square root of something squared, we get the something back again, y minus 5. But we get the absolute value because it doesn't. It's either going to be y minus 5 or 5 minus y, and, you know, we can take the absolute value of that. It's always going to be a positive number. Let me put that one. 3 times, and this is going to be the absolute value of x minus 1. Do you see? Because it happened to be that I can just take the square root of both sides, and I can see that that's what that equation is going to become, which is just the line. Y minus 5 equals 3 times x minus 1, point slope form. You can see what the line would be here. It would have a slope of 3, positive or negative 3, and that's going to be your 2 lines right there. And it's going to, you can see what points it's going to pass through real easily. All right, well that's just going to, so this is really just the solution right here. That's what it's going to degenerate to, this line right here. But that's not the equation, and that's what the problem is, to find the equation of this degenerate hyperbola. So to do that, I'm going to go back, and I hope I can kind of just come back here. Well, maybe I'll do it up over here. Right here, what I could have done instead, and the way I would have worked this problem out right here, instead of taking the square root of both sides, I could have gone ahead and just squared both sides. So from right here, I could have squared both sides to get rid of the square root, because usually when I have equations involving square roots, this is what I normally do. And this will give me the equation of the hyperbola. And so I can see the square root of, it just undoes the square root, right? So I'm going to get over here. My second step after this then would become, so kind of come up over here with me, okay? It would become y minus 5, that whole quantity squared, equals 3 squared, which is 9, times x minus 1, quantity squared. And then I could think of this as, think about it, okay? I could think of this as, well, I hope I don't throw you off too much, just doing this. 9 times x minus 1, quantity squared, minus y minus 5, quantity squared, equals 0. All I did was take the 9 times x minus 1 squared, take it over to the left side, and it became negative, but then I multiplied everything by negative 1. So do you see how this is a hyperbola, kind of with a radius of 0, kind of like a circle with a radius of 0. All right, now if you don't want, if that messes you up, you could think of it this way too. Let me see if I can just erase that part right there. It's not wanting to do that. But at any rate, you could work it all the way out too. 9 times, and I could take this as x squared minus 2x, would that be yet plus 1? Yeah. Minus, and then what would I get here? Y squared, and then we get minus 10y, so plus 10y. And then you'd get y squared minus 10y plus 25, so minus 25 equals 0. So, I mean, I could work this out, right? And so then I'm going to get here, I think I don't want this right here. I don't want this. Can I just get rid of that? Does that work? Oh, yeah, it does. Look. Oh, nice. Okay, so we're going to get here 9x squared minus 18x plus 9 minus y squared plus 10y minus 25 equals 0. And then let's see. Let me see what I get here. I would get 9x squared, right? And I think minus 18x, I think this is going to give me my final answer. Minus y squared plus 10y. Let's see, minus 25 plus 9. Is that going to be minus 16? Equals 0. Yeah, and again, so this is also my final answer right here. That is the equation of the hyperbola that degenerates to these 2 lines right here, and you can see why you don't really have to square both sides here. You could just take the square root of both sides, and then that would degenerate to the line. But if I go ahead and square both sides like I did in all the other problems, you can see you get the equation to the hyperbola. All right, hopefully that makes sense. That's a very long explanation, detailed explanation, and hopefully that helps anybody out that's struggling with that. Okay, talk to you guys later. Bye.